All right, guys. So today we are going to do a little bit more on complex numbers since you got a kind of a drive-by complex number review yesterday. And we are also going to work on solving quadratic equations in other ways. So if you want to write down these problems, these are the ones that we'll do together in just a second. All right, so let's work on multiplying two complex numbers. And so I've thrown in pretty ugly radicals because that way I figured it'd be good for you to see some of the tougher ones with me. So you're going to start out and you're going to FOIL. So first is 5 times 2 or 10. Outer is 5 times 2 square root 2i, which would be 10 square root 2i. Inner is negative 3 square root 2 times positive 2. So that would be negative 6 square root 2i. Now, last is going to be negative 3 square root 2i times positive 2 square root 2i. So let's work on this, and I hope the focus comes in. Sometimes it starts doing better after a second, sorry. So I'm going to do it in little chunks. The negative 3 times the 2 part is negative 6. Square root 2 times square root 2, remember, square root 2 times square root 2 is square root 4, and that's just plain 2. So it would be negative 6 times plain 2, and then I times I is I squared. So now what I have to do is remember that I've got 10 plus, look here, 10 square root 2 and 6 square root 2i. Those are like terms. So 10 minus 6 is 4, and the square root 2i, this is like saying 10x minus 6x. So you get 4x. Now, this is going to be negative 12. And then remember, I squared is negative 1. Oh, so look, this is 12 and 10, which together makes 22. And then plus 4 square root 2i. So as a review from yesterday, remember this is a plus bi form. And that's what you need, okay? So now, let me say, let's do 15 minus 4i quantity squared. So guys, remember that means 15 minus 4i times 15 minus 4i. So we're going to do the exact same thing. We're going to FOIL. So this one might be simpler, but it's got large numbers. So first is 15 times 15. That's 225. Outer is 15 times negative 4i. That's negative 60i. Inner is negative 4i times 15, so that's again negative 60i. Last is negative 4i times negative 4i, which is positive 16i squared. Now remember, we know that 16i squared is negative 16. So you're going to put that negative 16 with 225. So I'm going to punch that in on my calculator like you will. I don't know if you could see that, but negative 16. I don't know if I'm getting that or not. Plus 225. All I'm doing is adding. It's not a big deal. So that's 209. So my A part's 209. And then the negative 60i and the negative 60i add up to negative 120i. So that's just a review of multiplying. And that was about the hardest thing we did yesterday. So the next problems that we're going to do are going to multiply by conjugates. So if you want to take a minute, pause the video, write these problems down on your notes, so then you can work them out with me. All right, so first of all, you need to know what conjugates are. So conjugates are just, I'll write it here and then I'll erase it. If you're talking about conjugates, you're talking about A plus BI and A minus BI. That's a pair of conjugates. So all you do is keep the real part the same and do the opposite of the imaginary part. So what I'm going to do here is say, well, then negative 2 plus 9i's conjugate is negative 2, and then just go from positive 9i to negative 2i. And it says to multiply those, all right? So when you FOIL, negative 2 times negative 2 is positive 4. Negative 2 times negative 9 is positive 18, and there's an I there. Positive 9 times negative 2 is negative 18, and there's an I there. And last but not least, negative 9 times positive 9 is negative 81I squared. Okay? Now, since you're doing A plus B and A minus B, the middle terms are going to cancel out, because what this basically is the factoring of a difference of squares. So the middles are always going to cancel. And then remember, this is positive 81 with positive 4 is positive 85. So if you have 6 minus 7i, its conjugate is 6, but go from negative 7i to positive 7i. And again, when you FOIL, first is 36. Outer is 6 times positive 7, which is positive 42i. Inner is 6 times negative 7, which is negative 42i. Last is negative 49i squared. So once again, because you've got opposite signs here, the inner parts are going to cancel each other. So you're just left with the first and the last part of FOIL. So remember, negative 49 is the same thing as negative 49i squared is the same thing as positive 49. So if I have positive 49 and positive 36, when I add, I get 15. That's going to be 85. So what I want to show you is that there's a pattern. Whenever you multiply a pair of conjugates by each other, your answer is one nice, neat, real number. It's not always 85. That is a complete coincidence. So you'll see some that aren't. So again, the big idea I want you to take here is if you multiply a pair of complex conjugates, you get a real answer. It doesn't have to be 85. Again, I didn't realize I made up 2 problems with the same answer. Completely coincidental. So now we're going to use the idea of conjugates to help us divide by complex numbers. And this is also going to help us review multiplying. So go ahead and write these 2 problems down in your notes, and then we'll do those together. Pause the video if you need to. All right, so here's the deal. You're not allowed to have radicals on the bottom of a fraction. So you all are used to saying, okay, I can't have 6 over the square root of 3 and leave it that way. Y'all are used to saying, well, I've got to make that square root of 3 over square root of 3, where you're multiplying the fraction by 1, and multiplying by 1 is always legal. So when you multiply straight across the top, you get 6 square root 3. When you multiply straight across the bottom, you get square root 3 times square root 3 is the square root of 9, which is plain 3. And then you go, oh, look, 3 goes into 6 twice. So your answer is 2 square root 3. You're used to doing that, okay? What's similar to this is if I said, well, what about 6 divided by I? Well, remember, I is a radical. It's the square root of negative 1. So we do the same thing. You say times I over I. So that's going to give you 6i on the top, I squared on the bottom. And remember, this is like saying 6i divided by I squared is negative 1. So 6 divided by negative 1 is negative 6, and just I. So you've seen that before, all right? Well, I'm refreshing you because it might have been a while. Let me show you what else you've seen before, although it's been a while. If I had something like 1 over 2 plus the square root of 3, you have seen again that if you have a binomial and you can't have a radical on the bottom, then you multiply by the conjugate here as well. And look, I'm making this fraction equal to 1, and then you're always allowed to multiply by 1. So straight across the top, I would do 2 minus the square root of 3. Straight across the bottom, I would create a FOIL problem, and I would work this out. So I would have 2 times 2 is 4. Outer is negative 2 square root 3. Inner is positive 2 square root 3. So because you have conjugates, outer and inner are going to cancel. And then last is negative square root 9 or negative 3. And then look at that. That's 2 minus the square root of 3 over 1. And you know you don't have to write over 1. So there's your answer. And you took care of the radical on the bottom. Well, these problems are the same idea, okay? So we know if we multiply a pair of conjugates by each other, I'm going to hope that the video, I can see that the camera's getting messy. If it doesn't clear up by the time I'm done writing, I'll pause until it clears. Okay, I'm back. So you multiply by 1. All right, you're only allowed to multiply fractions by 1 without changing the fraction's value. So I use the conjugate of 8 minus I, and that's 8 plus I. On the top, it's 4 times all of 8 plus I. So this creates a problem where you distribute, and I get 32 plus 4I. On the bottom, it's a FOIL problem. Well, first is 64. Outer is plus 8I. Inner is minus 8I, and those should cancel each other. And then, and I can write that down, and you can always double check it. And then last is minus I squared. So if you're doing it right, the plus and minus I parts on the bottom should cancel out. Now I've got 32 plus 4I, and I'm going to show you what I'm going to do. I need to go to A plus BI form. So instead of writing it as a condensed fraction, I'm going to split it here. Notice this is 64 minus 1, 64 plus 1, because minus I squared is the same thing as positive 1, with 64 is 65. 32 65ths does not reduce. 4 65ths does not reduce. And that I can either be written on the top with the 4, or you can say it's 4 65ths I, and it can be written beside the fraction. Now, I'm going to do the same thing here. This one's just a little messier because I threw in radicals. So the conjugate of the bottom is 1 minus the square root of 2I. I can only multiply by 1 without changing the problem itself. So I have to multiply by 1 by making the top and bottom the same. The top becomes a distribute problem. The bottom becomes a FOIL problem. So when I distribute here, I get 10 minus 10 square root 2I. On the bottom, I have 1. Look, this is going to be negative square root 2I. Inner is going to be positive square root 2I, so those cancel. Last is going to be negative. Root 2 times root 2 is root 4, which is 2. I times I is I squared. All right, so I've got 10 minus 10 square root 2, I. Negative 2I squared is the same thing as positive 2. So 2 plus 1 is 3. So I'm going to go ahead and separate. So I've got A plus BI form, and I don't have to write additional steps. And 10/3 and 10/3, those don't reduce. So you're done. Here are the last 2 problems I'm going to do with this concept. Copy them down, pause the video if you need to, and be ready to go. All right, so on this one, it's just a little harder because the last ones I had a real number at the top. Now I have an I number at the top, which makes the top a little bit more messy. But 3 minus 7i's conjugate is 3 plus 7i. And then the top and bottom have to be the same so that this fraction equals 1. So again, the top here is a distribute problem. You just got to be more careful. The bottom is a FOIL problem. So I distribute and get 12i plus 28i squared. On the bottom, first is 9. Outer is plus 21i. Inner is negative 21i, so those cancel. Last is negative 49i squared. All right, so this 28i squared, guys, is negative 28, and it has to go first because we make the real part lead. It always goes before the imaginary part, and then the 12i goes second. Now, the negative 49i squared is positive 49, and 49 plus 9, I think, is 58. So what I'm going to do is I'm going to go ahead and separate, because I burn a step if I wrote it all together, and then I would have to separate on a separate step. So I'm just going to do it all at once. But look, I noticed these are both even. So 2 at least divides in, maybe 4. But 2 goes into negative 28, negative 14. 2 goes into 58, I think 29, so you're done with that part. 2 goes into 12, 6, and 2 goes into 58, 29. So that's your messy fraction that you end with. Now, the last one, it's the same rule. It's just a little bit bigger problem. So the problem is having the 5 on the bottom. So you use the conjugate of the bottom, so you clean the bottom up. You're only allowed to multiply by 1 without changing the fraction. So my top and bottom have to match so that I'm multiplying a fraction of 1. So now look, what's hard about this problem is both the top and the bottom have become FOIL problems. So the concept's not harder, but finishing the problem takes a little more time. So on the top, first is 2. Outer is 10i. I'm going to go all the way through the steps this time. Inner is 3i, so those should not cancel each other out. Last is plus 15i squared. On the bottom, first is 1. Outer is plus 5i. Inner is minus 5i. Last is minus 25i squared. Remember, on the bottom, if you're doing it right, inner, outer will cancel. So look, the 15i squared is negative 15. Negative 15 with a positive 2 is negative 13. I have 10i and 3i, which I'll put together as 13i. It's just a coinkydink, again, that they're both 13. Now on the bottom, minus 25i squared means positive 25, and 1 is positive 26. That goes under the A and the B part of the top. Oh, and it looks like 13 over 26 reduces to 1/2. So my final answer winds up prettier than expected, negative 1/2 plus 13/26 is again 1/2 I. So I've got an A plus BI form. Now we're going to part 2 of our lesson. So the second part of our lesson is to solve quadratic equations. And we're going to review quickly the 4 ways you can solve quadratic equations. And in these next ones, we are going to solve using the quadratic formula. So I want to remind you that as we go, we can use the discriminant, and I'll remind you what that is. So we can tell if you're going to get 2 real answers that are different, 1 real answer that you get twice, so it's a repeated real answer, or if you get no real answers, and that means you get 2 non-real answers that are complex conjugates. Write this problem down and I'll meet you on the other side. So I want to remind you what you learned in Algebra 2A and probably talked about it in Algebra 1 as well. There are 4 ways to solve quadratic equations. The absolute easiest way to solve the equations is to take square roots of both sides, but most equations are not set up to do this. But if they are set up to do it, it's the easiest and fastest. We'll talk about that next. The next way is to factor. Guys, you just had a quiz on solving equations by factoring, so we've done this one. So I'll check it off. We have done that. We're going to do this today. So I'll put a smiley face. This is coming. We're also going to use the quadratic formula. Now, after you take square roots and factor, completing the square is really, really easy and neat when it's got particular characteristics, when it's really super neat. It works all the time, but sometimes it's so messy you want to avoid it. And then also using quadratic formula works all the time. The problem is that this is a way that really only works if you've got a calculator, and it doesn't apply to lots of other problems. Factoring, for instance, applies to lots and lots of problems, so that's why we really focus on it most. Now, you've got 4x squared plus 4x minus 11. This is a quadratic equation because it's got x squared. Since it's got x squared in it and it's an equals 0, I know that I'm going to get 2 answers. And so I've got to end with x equals this and x equals that. So remember, when you do this, we've got it in ax squared plus bx plus c form, and it's got to be equal to 0, so it's already that way. But this tells me that my a is 4, my b is also 4, and my c is a negative 11. So I'm going to sing. You're just going to have to be all right with it. So I'm going to say x equals negative b, so negative 4. plus or minus the square root of b squared. Go ahead and do b squared. So 4 squared is 16. Guys, this is always positive. Minus 4ac all over 2a. So go ahead and do b squared and go ahead and do 2a. Now, I'm always going to say set the step up first. That's the first thing I'm checking. The second thing I'm checking is for you to get the number under the radical down to a single number. So I'm simply on my calculator going to punch in 16 minus 4 parentheses negative 11. Enter. So I plugged it in exactly like that, and I got 192 all over 8. Now, if the 192 simplifies, you need to simplify it, and I'm almost sure it does. Something tells me, I'm not sure, but I'm going to do some scratch work over here. I think the square root of 192 is divisible by 16, which is a perfect square. I'm doing that 192 divided by 16 on my calculator is 12. Now, wait a minute. 12 is divisible by 4. Oh, 192 divided by 64. I can make this a bigger perfect square, 64 times 3. And then I can make that 8 square root 3. So that's just scratch work. So I'm going to put 8 square root 3 right here. So now what you can do is say, all right, so that's negative 4/8 plus or minus 8 square root 3 over 8. So I'm separating it into parts. Negative 4/8 is negative 1/2. And then 8/8 is just 1. So I can make it negative 1/2 plus or minus the square root of 3. So that means if I wanted to write individual answers, I bet you can't see this, then my individual answers would be x equals negative 1/2 plus square root 3. And if you were supposed to do a decimal answer, like on my math lab, you would punch that in your calculator. And your other answer is x equals negative 1/2 minus square root 3. So these are conjugates of each other, guys. And again, if my math lab asks for decimals, you'll plug those two individual answers in on your calculator. Oh, I was going to mention this too. You can tell by the discriminant whether you're going to get two answers that are real and different, one answer that's real and repeated, or you get two non-real answers. So you see when I got down to 192 under the radical, well, it was positive. So anytime you get the square root of one positive number, that's telling you you're going to get two real solutions. And I mean that you're going to get two answers that are different from each other. Copy this one down. I've made it have fractions because I want you to know how to deal with fractions and how to clean this equation up. All right, so with an equation like this, if you've got a lot of fractions, I would clear fractions first. But on this one, I can go ahead and say, well, let me do 9x minus 5x. And let me do 20 minus 34. I need it all equal to 0. But guys, I never, ever, ever solve quadratic formula or factor or complete the square for that matter, if I lead with a negative or if I have any fractions. So what I want to do is clear the negative out and the fraction by multiplying everything by negative 3. So negative 3 times negative 1/3 is positive 1x squared, and that's what I want. Negative 3 times positive 4 is negative 12x. Negative 3 times negative 14 is positive 42. Negative 3 times 0 is just 0. So now I can see that A is 1, B is negative 12, and C is 42. And we're practicing the quadratic formula. So x equals negative b plus or minus the square root of b squared. Remember, negative 12 squared is still positive 144. That's always positive. Minus 4ac all over 2a. So I always start with this. Your second step is to always take the number into the radical and get it down to one single number. So on my calculator, I'm punching in 144 minus 4 parentheses 1 parentheses 42. I'm just going to punch it in as is. That's giving me negative 24. Now, we talked about the discriminant. Now you see that we've got the square root of a negative. And anytime you have the square root of a negative number, you're going to get two non-real solutions. All right? So I'm expecting to get I answers. So what I'm going to do is I'm going to say, okay, break that down. I'm going to do scratch work again. The square root of negative 24 is the square root of 4, because that's my perfect square, times 6 times negative 1. So that's 2 square root 6. And remember, that's I. So I'm going to put that here, 2 square root 6 I. And then I've still got over 2. Well, I'm going to go ahead and separate and say over 2, because I've got to separate it anyway. Well, that's going to be 12 over 2, which is 6, plus or minus. 2 over 2 completely cancels. So plus or minus the square root of 6i. So you can answer like this, but that also means that one of your answers is 6 plus the square root of 6i, and the other answer is 6 minus the square root of 6i. So these are two different complex answers or non-real answers, and they are conjugates of each other. Here's your next problem. I'm making the equations longer and longer, but never fear, we'll work it out. So on this one, what I have to do is start out and get everything to the left equals 0 to the right. So 32 minus the 7 is 25. Negative 41 minus the 29 is negative 70. And 43 plus the 2 is 45. Now I can go straight from here, but I want to show you something. Do you notice that all of these numbers are divisible by 5? You can make your numbers smaller if you want to, and I like to. So I could say, okay, 25 divided by 5 is 5. 70 divided by 5, I think, is negative 14. 45 divided by 5 is 9. And 0 divided by 5 is 0. And then my numbers are a little smaller. So notice you've got A is 5, B is negative 14, and C is 9. So here we go. X equals negative B plus or minus the square root of B squared. Negative 14 times negative 14 is positive 196 minus 4AC all over 2A. So we're setting it up the same time every way, the same way every time. That's what I want you to do. So I'm going to plug in on my calculator 196 minus 4 parentheses 5 parentheses 9, just like it is. I get 16. Ooh, I like this. This is a nice problem. Now, here's what I know. My discriminant is 16. That just is the number under the radical. So remember, if you take the square root of a positive number, I know that we're going to get two real solutions. We always get two solutions, but I'm saying when I say two reals, I'm saying they're real and they're different from each other. So let's proceed. This is a nice one. So x equals 14 plus or minus the square root of 16, which is a nice 4 over 10. Now, I'm going to say that means that x is either 14 plus 4 over 10, which is 18 over 10. Divide by 2 is 9/5. Or x equals 14 minus 4 over 10, which is 10 over 10, or 1. So those are your nice, neat solutions. Copy this down. This is your last quadratic formula problem. Okay, so here we are. We're going to do the same thing that we did a second ago. Add x squared over, get 2x squared. Subtract 11x over, 23 minus the 11 is 12x. Add the 19 over, Negative 1 plus 19 is 18 equals 0. Just like the last time, I happen to notice that all my numbers are divisible by 2. You're not required to make the number smaller, but I like to. 2 divided by 2 is 1x squared. 12 divided by 2 is 6. 18 divided by 2 is 9. And 0 divided by 2 is 0. We're going to go into the quadratic formula because that's what we're practicing. A is 1, B is 6, C is 9. X equals negative B plus or minus the square root. B squared is 6 squared. It's always positive. Minus 4AC all over 2A. Now your next job is always to get one single number under the radical. So if you punch this in your calculator or if you do in your head, you're going to get 0. So this is the one we've not talked about. This time our discriminant is 0. Guys, if your discriminant is 0, that's telling you that you're going to get one real solution. Now I need to qualify this. Every quadratic equation has 2 solutions. What this is saying is you're going to get the same answer twice. So a better way to say it is that you're going to get one real solution that's repeated, all right? So when you look at this, this means that x is either equal to negative 6 plus the square root of 0, which is 0, or that x equals negative 6 minus the square root of 0, which is 0, all over 2. Negative 6 plus 0 is negative 6, over 2 is negative 3. Negative 6 minus 0 is negative 6, over 2 is negative 3. So see, you're getting the same answer twice. So if you were doing handwritten work, you would tend to say negative 3 is a double root, and you put the little d to show that it comes up twice. But if you're on My Math Lab, and they say x equals, and you're supposed to type into the box, they just mean for you to write negative 3 and nothing else. We're done with quadratic formula. On to our last topic. So now we're to my favorite ones. I love to take square roots of both sides. So we need to make sure you know when you can take square roots of both sides. Copy these problems for our notes, by the way. So in this problem, you see there's only one x in the problem, and it's the x squared. That's a tip that you can take square roots. This time there's only one x in the problem, but it is inside the squared piece. So if you have an x squared and an x in the problem, you can't take square roots. But if there's only one x in the problem and it's the x squared part, it's a take square roots problem. So here we go. Now, if you're going to take square roots of both sides, you've got to isolate x squared. In this case, I've got to add the 15. So negative 9 plus 15 is 6. Now I need to get rid of the fraction. So I'm going to multiply both sides by 4/3. So the 3's and the 4's cancel top to bottom here. So I'm left with 1x squared. That was my goal. Here I'm going to say 3 goes into 6 twice, and 2 times 4 is 8. Now I'm going to make this big space here because when you take the square root of both sides, I want to remind you that you have to introduce the plus or minus so that you do get the 2 different answers. So the square root of x squared is just x. And remember, 8 is equal to good square root times bad square root. 4 is the perfect square that goes into 8. So you've got plus or minus 2 square root 2. And those are your 2 different answers. So on this one, the squared part is already isolated. So I'm going to take the square root of both sides. Remember, you have to take plus or minus the square root of the right-hand side. So the square root and the square just kind of melt each other away. So you're left with 2x plus 1. And of course, plus or minus 81 is plus or minus 9. So now I'm going to subtract 1 to the other side. So I need to figure out what that number is. So negative 1 plus 9 is 8. And negative 1 minus 9 is negative 10. So now divide everything by 2. And you'll have x equals 8 divided by 2 You'll also have negative 10 divided by 2. So I like that one. It worked out with two nice, neat numbers. A couple more coming at you. Go ahead and copy these two problems, and we'll talk about why they're take square roots problems, and we'll talk about how to solve them. You've got 4 examples left, these 2 and 2 more. So these 2 problems are both take square root problems because, again, if you look, I only have one x in this problem, and the x is inside the squared piece of the problem, so I can take square roots. Ditto on this one. There's only one x in the problem, and it's just x squared. So if you had x squared and something else with an x on it, take square roots is out. But if it's just x squared and a bunch of numbers, take square roots is in. So on this one, I need to isolate the x minus 5 squared part. So the first thing I'm going to do is subtract 6. So 45 minus 6, I think, is 39. Then I'm going to divide by 3. So x minus 5 squared equals 13. And I'm going to put a big space there because I'm ready to take square roots of both sides. So I've got to introduce that plus or minus. So I get x minus 5 equals plus or minus, and the square root of 13 does not break down. If you think about your perfect squares, you've got 1 squared, 2 squared, 3 squared, 4 squared. So the only perfect squares less than 13 are 1, 4, and 9. None of those go into 13. So you don't do anything with that. So to isolate x, you just add the 5 over between the equal sign and the plus or minus. So 5 plus the square root of 13 is one answer. 5 minus the square root of 13 is the other. It's 2 different real answers, and they are conjugates of each other. Now on this next problem, you simply need to move the negative 72 over. Again, I'm going to make that big space because I know I'm ready to take the square root of both sides. Oh, so we're doing this one because you've got imaginary answers because you're taking the square root of a negative. So I'm going to have plus or minus. Now remember, what you want to do is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared. 9 squared is too big. So start with 64. The 64 going to 72. This 49 going to 72. This 36 going to 72. Yes. So if you will start with the largest perfect square first, you're going to break it down the fastest. So it's 36 times 2, and then times a negative 1. Those 36 times 2 times negative 1 equals the negative 72. And remember, in my classroom, I have the list of perfect squares on my board, so you can just kind of look at those to speed you along. So the square root of the 36 is the 6 part. The square root of 2 is just the square root of 2. You can't do anything with that. And the square root of negative 1 is your I. So you've got 2 non-real answers that are different. 6 square root 2i and negative square root 2i. My auto lights just came off on me. So I want to remind you, if you like writing it 6i square root 2, A-okay, A-okay. Either way is fine. Here are your last 2 problems. They're a little messier because I'm throwing in some weird stuff with i's and radicals. So copy them down. Let's do these 2 and you are out. All right, last problems. So here, there's only one x in the problem. It's the x squared, so it's a take square roots problem. I isolate 3x squared. 5 minus 12 is negative 7. Then I isolate x squared and get negative 7/3. So I want to remind you how you take the square root of a fraction. So the square root of the x squared is x. That's equal to plus or minus the square root of the negative 7 over the square root of 3. So you need to go ahead and separate square root top, square root bottom. Multiply by the square root of 3 over the square root of 3. So x equals plus or minus, that would be the square root of negative 21. But let's go ahead and make it the square root of 21i. And then you have square root 3 times square root 3 is just square root 9, which is plain 3. And I'm running out of juice on this marker here. All right. I want to remind you guys that if it had been the square root of -8, for instance, over the square root of 3, in this case, you would have said, wait a minute, 8 is 4 times 2, so I can make it 2 square root 2, and I'll go ahead and make it I. So if either the top or the bottom breaks down, break it down first, then multiply by the square root of 3 over the square root of 3, okay? So that would have been 2. Square root 2 times square root 3 is square root 6, and then I. And on the bottom, square root 3 times square root 3 is again 3. 2 and 3 are my regular numbers, but they don't reduce, so that one's done. So I just wanted to mention to you how to do the square roots of fractions, because you saw it last year, but it's been a while. You've not seen it this year. So this is also a take square roots problem because the only x in the problem is inside the squared piece of the problem. So I need to isolate the x minus 8 squared part. And I do that by first subtracting 5. So -45 minus 5 is -50. I need to clear the fraction now. So multiply both sides by 3 over 1. So that my 3's cancel and I'm just left with x minus 8 squared. And this is just going to be -50. I'm putting that big gap there. So I'm going to take the square root of both sides, and you can either write that out or not. I didn't write it on this side. I talked about it, but didn't write it. The square root of x minus 8 squared just leaves you x minus 8. Remember, what perfect square goes into 150? Well, what goes into 50? 25. So it turns out that it's 25 times 6. And then remember, times your -1. So I'm going to do two things at once because I can. I know I need to add the 8 over. So I'm going to put it between the equal sign and the plus or minus. I know the square root of 25 is 5. The square root of 6 is the square root of 6. And the square root of the -1 is I. And you're done. All right. So you're ready to rock and roll on the practice work. And I will see you in class in a day or two.